Good day everyone, I'm Ayumi Melchor from BSIT 3rd year 5. I will be presenting a midterm laboratory activity 4 which focuses on creating a restaurant order management system using Python list. This activity simulates how menus, orders, and basic restaurant operations work in real-life food businesses, such as fast food chains, cafes, and restaurants. The program demonstrates how to store menu items, add and remove dishes, search items, sort prices, take customer orders, and generate a simple bill summary. It also highlights how list methods can be used to manage dynamic data within a system. The main objective of this program is allow the user acting as the cashier or admin to manage restaurant menu data efficiently. The system must be able to display the menu, insert new dishes, remove or pop items, sort and reverse the list, search for specific dishes, take orders, and compute the total bill. Ultimately, the goal of the activity is to show how these methods in Python can be used to build a simple but functional food ordering system. The first part of the program initializes the restaurant menu. The menu is created using a list where each item contains the dish name and its price. The list represents the restaurant's available products. The program then prints the menu in clean, numbered format so that the user can clearly see all the available dishes. This step establishes the foundation of system, giving us a structural list that will be modified throughout the entire activity. And the next part of the program shows how to add new items to the menu. Two important list methods are used. Append adds a new item at the end of the list. Insert adds a new item at a specific position. The system also asks the user to enter a new dish name and price. These are then added to the menu to simulate how a restaurant might update their menu in real life. After all additions, the program displays the updated menu so that the user can confirm the changes. And for removing and popping items. In this portion of the activity, the program demonstrates how to delete menu items, which users remove to delete a specific dish from the menu, and pop used to remove the last item from the list. This situation reflects real-life scenarios such as unavailable dishes, discontinued items, or menu revisions. After performing removal operations, the updated menu is printed again so the user can clearly see what has been deleted. And for sorting and reversing the menu, it highlights how to organize menu items based on their prices. First, the menu is sorted from the lowest price to the highest price. Then the program reverses the list to switch the order, placing the most expensive items at the top. Sorting helps create an organized display for both customers and cashiers, while reversing gives a different perspective, useful for promotions or highlighting premium dishes. And this section introduces two operations: item searching and price counting. The user is asked to type a dish name. If the dish exists in the menu, the system shows its price and index location. If not, the program displays an error message saying the item is not in the menu. The system also counts how many dishes cost more than 100 pesos. This demonstrates how Python lists can be used for basic data analysis within a business context. The program also includes a separate dessert menu. To merge the dessert items with the main menu, the program uses the extend method. This operation is commonly used in real-life systems, where restaurants combine categories such as meals, beverage, and desserts into one complete menu. And for one of the most important parts of the program is taking customer orders. An empty order list is created and the user can type in the dishes they want to order. If the dish is available, it is added to the order list. If it's not found, the program politely informs that the user that the item is unavailable. The ordering process continues until the user types the word done. This simulates how actual restaurant ordering system receive multiple inputs before final confirmation. And for the bill summary and total computation, after the customer finishes ordering, the program calculates the total bill. It displays an order summary showing each item ordered along with its price. Then the system computes the total amount that the customer needs to pay. This step shows how list data can be processed mathematically, which is essential in any sales or cashier system. And the final technical section demonstrates two more list methods. Which is copy method creates a backup version of the menu. Clear for completely empties the original menu. This is useful in real-life situations where managers might reset the menu for updates while keeping a backup for our record purposes. And this is the output of the program. This activity demonstrates how Python lists are used in real-world systems involving menu storage, inventory updates, customer ordering, price calculations, system backups, and restaurants, cafes, delivery apps, and food ordering systems all use the same logic behind the scenes. By using list methods such as append, insert, remove, pop, sort, reverse, extend, copy, and clear, The program becomes flexible and powerful enough to simulate actual restaurant operations. To summarize, midterm laboratory activity 4 uses list creation, modification, sorting, and data processing to build a functional restaurant order management system. The program demonstrates how Python can handle dynamic data while still being simple and efficient. It also shows how these operations play a major role in real business applications, such as food ordering, cashier system, and menu management. And that's all. Thank you for listening.